work in the resolution of 400 microvolt. So, moving on to the next part, decision time or the propagation delay. So, the strong arm latch decision time, basically the comparator only, the strong arm latch block. The propagation delay here is 600 picosecond, and the whole comparator, along with the preamplifier I showed previously, it has a propagation delay of 855 picosecond in the typical corner. And in the worst corner in the PVD analysis, the delay is 1.226 nanosecond. Since it's an edge-triggered circuit, on the clock's positive edges, the latch generates dynamic spikes. So the total average current is 14.60 microampere, which portrays that our circuitry is a low power circuitry. Low power consuming circuit. In terms of the Monte Carlo analysis, along with the preamplifier, the latch has one sigma offset of 40.908 microvolt. So the 3 sigma is like around approximately 0.123 millivolt. So again, this work has been implemented in the 55 nanometer CMOS technology. And the circuit operates at 3.3 volt, and we have made the circuit work at 220 megahertz speed. So here's one of our results.
So this circuit within 1 minute.
Here's our results. So basically, the LSB has to be VRAM divided by 2 to the power n number of bits. So we were like we have to make this comparative work in 805 microvolt, and this is the depiction of it. The latch can take decision property. This is the regeneration time, basically the propagation delay. So the latch comparator takes only 600 picoseconds, and the whole system takes around 855 picoseconds in the typical corner, and in the worst corner 1.226 nanoseconds. This is the power consumption. So whenever there is a regenerative action, we can see an instantaneous dynamic power spike. And this is the total power consumption, which includes both the dynamic and static components. So basically, it exhibits an average current consumption of 14.60 microampere, which tells us that it is a low power consuming device. So here's comparison table with the established work of this circuitry. So basically, it has been established in 65 nanometer technology before, and we have established this circuitry in 65 nanometer. And here are the parameters we have tested. This is the sensitivity, power supply, clock, frequency, energy comparison, delay output, and offset. So this is the comparison table basically. And I have to note that this work hasn't been implemented in 55 nanometer technology before. So this is the first time it has been done in this technology particularly. And we can see since the previous work was in 65 nanometer technology, in the 55